All right, so why would the potential energies be the same? So the reason they're the same is this. PE equals mgh. So they're both on Earth. So since they're both on Earth, G is the same value. It is 9.8. I'm not going to plug it in because it could be 45 or 13. It wouldn't make a difference. Okay, so I'm just going to write G for both of these. This first one has 2 kilograms for the mass, 1 meter for the height. Gives me a value of 2G. This one's got 1 kilogram for the mass and 2 meters for the height. Gives me a value of 2G. I wanted you to see that since there's no squares or anything, increasing one will have the same effect as increasing the other. If you make the height half and the mass half, they'll be the same effect. So increasing height, increasing mass, both do the same thing. So if you increase them by the same amount, one's twice as much, the other's twice as much, they'll have the same value still. So it is C. Have same potential energy. Excellent job, all you llamas and fish and whatever. Okay, next one. Ooh, flying condor. It's big time. Okay. All right, you expend 100 joules of work to climb a ladder. How much potential energy do you have at the top of the ladder? 0. 0 to 100, 100, or more than 100. There's this better. Good. It is 100. So one of the things we talked about in the notes is that the place that we get... What does gravitational potential energy of an object always equal? It always equals the work done to get it there. So since we do 100 joules to get up the ladder, we must have 100 joules of energy. This is why the 3-story slide at Washington Township Park is so boss, because you're higher off the ground, which means you have more potential energy. My kids go absolutely nuts for it because they're like, oh, we go so fast. Yeah, they have more energy. And that's because they have to do more work to get to the top. That's why my 4-year-old doesn't do it, because she doesn't like to have to climb that many ladders. Okay? So that one is going to be exactly 100 because that's how much work you did to get up there. Awesome job. Ooh, some shifts. Okay. All right, next one. 2-kilogram ball has about 40 joules when it's 2 meters above the floor. A 2-kilogram ball, your friend says, has 20 joules when it's 1 meter above a 1 meter table. So who's right? You or your friend? Or both. Maybe I'm messing with you. Nice job. Both. Because the difference is you're saying you're 2 meters above the floor. Your friend is saying you're 1 meter above a 1 meter high table. Which is still 2 meters above the floor. It's the same energy. And you're like, but they're not the same energy, right? One's 40 and one's 20. Well, this is half the energy because I'm looking at half the distance. And that is what it should be. They're exactly the same. It's just 2 different ways of thinking about it. Will there be a difference? No. But the way they're thinking about it, thinking about falling a meter to a table as opposed to falling 2 meters down, the overall effect is the same. So you can't fool me. Well, I probably can fool you. But both of them are going to be describing the same thing. Excellent job. That was good. More than half. Very good. Okay. Ooh, a hot streak. Oh, man. It happens. All right. 20 joules of work is done on a moving bicycle. How much does the cyclist's kinetic energy change? 0. 0 to 20, 20 or 20 or more than 20. How much does it change? Excellent job. It changes by 20. So in the notes we said work causes a change in kinetic energy. So if I do 20 joules of work, we should have 20 joules of kinetic energy change. But I should put it on the screen so you can see it. So however much work you do, that's how much kinetic energy change you'll have. So it is 20. Nice. All right, how are all the fancy zebras and number lizards and whatever? Okay? One more. Last one. A red car's got twice the speed, but the blue car's got twice the mass. Which has more kinetic energy? The red car, the blue car, or they're the same? Ooh! You guys are the first class to have the majority get it right. Not bad. It is the red car, and I know that so I've been picking C for all the answers, and I've been having all the weirdo, you can't fool me. Well, I decided to mix it up on this one. So, it's the red car. So why the red car? Let's go ahead and say that the standard mass is 1 kilogram, and the standard velocity is 1 meter per second. I'm just making that up. It doesn't matter. You can pick anything you want. The red car is going to have twice the speed. So it's going to have a mass of 1, but double the velocity, so a velocity of 2. 2 squared is 4, times 1 is 4, times a half is 2. The blue one, 1/2, doubled the mass. Blue car's got twice the mass, so this is 2 instead of 1. But the velocity is normal, so it's squared. 1 squared is 1, times 2 is 2, times half is 1. The red car has more kinetic energy. And the reason why the red car has more kinetic energy is because it's got more velocity, 1/2 mv squared. Velocity is king because it's squared. Mass is not. So that's what's going to affect it the most.